Yeah, I think I forgot to share the screen to record the things. But the bottom line here is that once you have M, the monthly payment that's ready, and the interest rate R, okay, for the annual return ready, then you are able to establish a list, okay, that consists of all the accumulated investments. And then if you look at the plots, then remember PLT here, matplotlib.pyplot, that package is now having a nickname of PLT. So PLT.figure is just getting FIG as the name of the figure that you establish. And then here, for the figure, you are plotting my savings as that list of investment amounts, right? And then make sure to give all the specify the title, the X or Y label, and then you'll be fine. So for a plot, so for the semicolon, let me get that to suppress. Okay, so you see the difference. The semicolon here is to suppress the print output for the last operation. So the last operation here is to give a Y label, okay, within the plot, okay. So that's exactly this, okay. Text, which gives you the string that you want for the Y label, which is not what you want in the cell printout. So that's a semicolon there to suppress the text printout. Okay. So title, X label is number of years working. The Y label is the investment amount. Okay. Oh, excuse me, the value of a retirement account. So once again, the prior values will be sort of accruing the interest, okay, in the sense that basically every year there's going to be like a projected annual return, right? So initially it's going to be for 0 years, okay? So at the beginning it will be a zero in the investment, and in the end, what do we need? We need at the 36th year, you're going to target at 750K, right? So that should be that amount. So also you may want to somehow specify, let's say the X range and the Y range, so that the figure looks a little bit better. So those are certain options that you can do. But the bottom line here is for one investment, okay, you should get a plot. Right. Any questions so far? So yeah, well here let's so there are a few cells. So let's try making it a class. Okay, so just notice if you only have we want to compare, right? So these are predetermined parameters that we have for. So we have the retirement age is 70. We want to live 15. We expect to live 15 more years, and then each year we need like a 50K retirement spending, and then the savings is gonna be basically how many years multiplying by the amount required each year. And then W is number of years that would work, okay, which is 70 minus the current age. And then we have R, okay, we have a bunch of interest rates, or basically the annual return possible for each investment. So remember, we had a choice of like three numbers, right? So we want to get the three different curves within one plot. So my recommendation here is to utilize the code that's established from before. Just you need to do it relatively systematically. Think about the figures that we have seen from before. We have let's see. We have like four figures that we established earlier. Okay, so basically, if you look at the class, okay, we want to get a class, and we just have the parameters that we need. in our retirement class. So if you think about the retirement, basically you have like we have like a target amount, and then you have like an annual raise, and then you have number of years, right? So basically the you need for earlier we need two sequences. So that's the monthly payment, that's self.paid, that's from earlier. Self.old is basically used to be the principal by every year, right? By the end of each year. But here we only need similarly two sequences. One is the monthly investment, excuse me, yearly investment, and the other one is what is the amount of values or the amount of money within the investment account, right? So those are the two sequences. And then make payment can be the same thing from before, just uh, basically the way that you sort of accumulate, okay, the investment amount. And then the total amount paid. Okay, so those are things really necessary, and there are things that may not be that important, so we may skip those. Okay, and then for the plotting, right? So, plot net. So this one, so yeah, depending on the figure. So earlier we only have the figure that's you have a sequence and then you just plot the numbers. So some of the things may not be necessary. And then in the classes that they may not be also they may not be necessary also. But then for the plotting, okay, we need this part. So basically, we need at least two things. We need the monthly payments. So that's a bunch of constant curves, right? And then we have the here we're gonna keep the balance. Okay, we're gonna keep that basically the amount of investments every year. So that's one figure that we need to sort of inherit. And then remember, basically, we need a numbering number label for the figures. And then for each figure, okay, so for each figure, I'm gonna have different X, Y labels and then the titles. And then also I'm gonna do, let me see. Yeah, for different investments. Okay, so just the structure of the code is going to be similar. It's going to be how many different investments we have for I within that range. I'm gonna every time I'm gonna for let's say this is a figure zero. I'm gonna plot investment I into that. I'm gonna do plot payments. So it just basically depending on what kind of thing that you want to plot, right? And then of course specify the legend. Mm, okay, so yeah, I'm gonna copy this entire cell and just modify, okay, along the way, so that essentially you in the future you may have some working template, but then you may want to make your own edits, okay, so that the things can work out. Right. So what do we have? So without referring back to that the top cell, let me copy these so that I can start from scratch. Let's say here, wait, here. Okay, let's specify the rates. So here it's not going to be a constant rate, but we have a like a small list. Okay, I'm gonna copy it here. So it's going to be a list without the dot. Okay, find M investment. That's my function. I'm gonna still utilize that. Okay, I'm gonna define the class. All right. So this one is gonna be suppressed. I'm gonna define a class. So now it's gonna be the class. Let's call it okay, retirement. That's good. Initiate. So what do we need? Of course, the investment has a self as the name, but then what do we need? We need the amount of say. Okay, that's necessary. Uh, the rate and the yeah. Okay, the rate and the number of years that's to work. All right, and specify. Okay, the parameters above. Okay, so basically all these parameters that are necessary. So, let me copy these. And also initiate the retirement age. So basically all these copied parameters I may want to specify retirement age, death age, retirement, retirement play, current age, retirement pay. Okay, so that, okay, these are the fundamentals. And savings probably don't need that. We can calculate along the way. So self dot retirement age is the input that we can specify. Self dot death age. Retirement age, retirement pay here, current age, and then of course the return. And then there's certain parameters we don't have to specify as input. Okay, so we can just calculate. But we are adjusting to the things within the class. Okay, so you are using self dot death age minus self dot retirement age multiplying by self dot retirement play. Okay, so retirement pay. But basically, depending on your inner parameter setting, and the monthly payment we can also get that. Okay, W is not needed here. W is not needed here, so it's the inner parameter. So W, and then the monthly payment. Okay, savings. Okay, good. And also payment, investment. Investment. So at the beginning, the investment is zero. Okay, so and then every month I'm gonna put some money, which is M. That's what we calculate. So yeah, saving rate W. Okay, so that should be fine right here. And my savings is also gonna begin with 0.0. And finally, of course, for initialization, we need legend, just similar to the mortgage for a mortgage class. legend. All right. So when you refer to the mortgage class, it's gonna be make payments, but here we're gonna do make investments. So docstring may not be necessary, but depending on your preference. Okay, so this is annual investment. So this part, okay, this part is inherited from before. So if you look at the cell from earlier, it's just what? It's just the previous saving multiplying by the interest rate, okay? 1 plus R. And then plus now the current monthly investment, okay? M, self.m right here. So it's actually from one of the cells earlier, okay? Right here, okay? Just remember, um, yeah, it's exactly this, okay? But now it's a self.r. It's self.my savings and self.m, right? So here there's only one sequence, okay? Only one list. But now you inside the class, we need to make it object specific, all right? So make payments every year is gonna be the previous, okay, the last element within my savings. And then I'm gonna multiply by 1 plus R, okay, occurring the return, right? Plusing the yearly value. So yeah, that's the old make payments function, but now it's now making yearly investments. And of course, if you want to calculate how much you have already sort of like invested, right? So define total, okay, okay. So yeah, this is the old get total paid function, but now we can just get total invested, right? So this is like incremental updates, okay? So just change whatever thing that you want to change, up to your choice. And yeah, so that's remember we're looking at the my investments, okay? So those are the amounts that I put down every year. So that's what we are summing, which is fine. So that's investment so far. Investments so far. And the class is almost done. So for the string function of my object, I can just print out my legend. But just here, just notice that the legend is none. Later, when you specify each investment, you can specify the legend later, okay, depending on your interest rate. And let me see. Finally, if you go back to so here these are the plotting the investments. But to quickly refer back to what we have earlier, so there are two things within the mortgage class that we established right here. Okay, so those are all right. So those are the functions you want to also plot. So depending on the curves, right? So earlier we have four curves. We have the payment curve, which are constant, and then we have the investment curves. We have the remainder principal, which is a decreasing curve, and then we have like the amounts of like interest that you have paid throughout. This is also an increasing curve. But here we only need two, right? So we just copy these two and then modify. So we have, once again, like the yearly investment that we want to plot and the balance, all right, in the investments that we want to plot. Okay, so just keep in mind those are the curves that you need. Then just copy them down and modify along the way. So that's going to be a style. Okay, so for each investment, you're going to have a specific style that you don't really have to change. But now remember, we have earlier we have paid and owed as two sequences. Now we have different names, right? So we have investments. Okay, so investments are the yearly investment. I'm gonna copy and paste here. So the yearly payment used to be 0. And it doesn't do anything in the curve, so I'm gonna remove that first element without plotting, right? Yeah, everything else doesn't have to change. And here we don't have old, we have the savings, okay? We have the amount of savings. So this is indeed really incremental, all right? So we can do it really systematically. Just try to preserve the old curve, but not make it too dramatic. So yeah, if you want to change the naming, it's also fine. So I'm gonna name it as like total saving. Excuse me. Plot total uh, savings and plot investments. And yeah, and I don't think this is needed anymore. But that's not it. Right. So yeah, that's pretty much it for the class. Okay, just remember when you want to plot, you may also want to include the plotting of the two curves within your class and execute. Wait, why is it okay? I see. Uh, something here has been executed. So okay, that's okay. This okay, that's the print savings that we didn't kill off, so we can kill that off. All right. Okay, so there's nothing there. All right, and plot. Okay, so you can do it in like a reverse order. So compare investments. This is the sort of like the main routine, right? And then we have the inputs. Let's copy from above. These are the things that we want to input. Retirement age, death age, current age, retirement pay, and just remember now we have the interest rates as this is like a list. Okay, so that's the only thing sort of like different from the initialization of my class, right? And that's not needed. So I'm gonna get a list of investments. So remember what they do, okay? So basically you have 3 different mortgages, and then you're gonna put it in a list. So they are not really necessary, but basically I'm gonna do a loop. So remember, every interest rate will give you a different investment. So what I'm doing here is I'm gonna establish the the list of investments, but then using a loop. So that can be done easily. So for let's say I'm gonna use an index because for each index, the things that need to be done for the particular interest rate. So it's gonna be index in range. Wait. All right, that's good. I'm gonna append. Right, so making the retirement plan and also specifying the legend. Index legend. Okay, so the legend, let's see. In that, so we only need to specify the percentage, okay, the annual return. So let's make an F string. So basically, if you think about the populated lines, they essentially generated from the code above. Okay, so which is usually helpful, but sometimes it's really up to your modification. So make it an F string so that everything becomes nicer. So that's basically the interest rate. But it's possible that it will have a really long kind of decimal representation. So I'm going to round it to two decimals. So basically, I'm going to say, okay, this is an investment with annual return that much percent. Okay, so that's going to be a good label. If you want to make it shorter, you can abbreviate a little. Right. All right. So now, that's basically setting up the three investments. Okay, so that's that part. That's covered. And now here, this is doing what? This part. Okay, for comparing the investments. That's what. That's basically making. Earlier it was making monthly payments, but now here we're making yearly investments. So it's the same thing. It's just you need to change the um things a little bit appropriately. Okay, so it's gonna be the number of years. So it's gonna be W. Okay, so it's gonna be. Let's be careful. We have a yeah. It's just the dot W. Okay, so number of years to work. So we can directly call that. I'm just making sure that I have the right variable. So it's gonna be what it's gonna be invest at the index. Yeah, I'm gonna make it further indented so I can utilize the index and dot W. Right, and then I'm gonna get rid of this. I'm gonna do the payment. Okay, it's not really make payments anymore. It's make investments, I think. Okay, make investments right here. Investment here and plot. Okay, so now the last line is plotting. Okay, so basically I have sort of like edited the outer loop, okay, for the main procedure. So once again, what do we do? So for every interest rate, I'm gonna establish a new retirement plan, and then I'm gonna specify the legend. And then now for that particular investment, I'm gonna do the loop, okay, for every year. It's gonna be making the yearly investment all the way down to the end. And then finally, once all the investments and the sequences are, or the lists are computed, finally I'm gonna plot, right? So now, in order to plot, I need to change the data. Basically, modes are what? Modes are the all the investments. So I'm gonna directly adjust according to what we have earlier, and the amount is really up to, okay, what kind of value you want to specify right here. So let's just do savings. To be sure. I think savings is a global variable. Okay, I think that's okay, and I do need that. So let's just still calculate that. Wait, let me think. Yeah, why not? I just call the global variable. I think the saving is the same throughout. So this amount is savings equals to, I'm gonna for every investment is the same savings. Mm. Yeah, there's a lot of choices, but basically for every investment that you have, you always have the same savings amount that's calculated from the death age or the number of years you need to pay, and then the yearly payment. So yeah, well, everything is the same throughout the investments. So that's okay. That's the savings that I can utilize, and then I'm gonna put it here for the plotting purpose. Right. So the high level idea is like this. Okay. So generate the mortgage the investments, make the payments, and then once you have the data, then we utilize the cell above. Okay. So then we have the subroutine we need to sort of modify. So plot investments. Let me change the name. Plot investments. I'm gonna copy it here from top. Right. All right, so the styles, okay, so the styles are, we have three different mortgages, excuse me, investments. I'm gonna change different colors. So we have the continuous curve, we have the periodic changing, we have the dotted curves, right? But then B are the blues, okay, I can change to, let's say, uh, some other color like green, which is G, or red, okay, as R. So those are the options that you have, you probably have changed already. So we need two curves, right? So let's remove these ones. So we have the payments and costs that we can modify. So these ones we're not going to keep, all right? So also these ones we're not going to keep. Okay, so just remember what they are. those are setting up the legends, okay, x, y axis and the label of your figures. And then these are for each figure. I'm gonna get the plots of each curve into the particular plot. All right. And then these ones are specifying the location of the legends. So I can remove these. All right. So now it becomes much clearer. And now, so just remember that's okay. These are the investments, which are the payments. So just remember we have the yearly investments that we want to plot. Investments. All right. And then I'm gonna make the changes so that later I can be sure of what we are doing. All right. So, and then also change. So yearly investments, okay. Yearly investments of different um, retirement plans. So it's really up to your choice. Retirement plans. And if you think about AMT, okay, so what are they? They used to be the amount that you loan, right? So now they're the savings. So that they're the target values for your investments. So this change accordingly. So years, yearly payments. So the second curve is not going to be the cost, but it's going to be like the balance. Okay, so we can say this is yeah. So let's just name it balance. Balance. So really incremental. Okay, every time I'm slightly changing one thing, but I need to be sure of what I'm doing. And years working. Okay, that's my input x variable, you can say. Now those are the yearly balance. Okay, yearly balance of investment account. That's my Y label. And what else? The title here is yearly balance of different $7,500 750K retirement plans. Right. Yeah, pretty much done. Okay, so now remember what they are. These are basically for every investment I'm gonna plot. So now I just change accordingly. So remember the inputs are invs, right? So the investments, I'm gonna just copy and paste. Um, and also make sure that you are calling the correct plot functions. So just quickly refer, okay, these are plot investments. So those are the monthly payments from before. And the plot savings, total savings, right? So that's the sequence that I want to plot. I'm not plotting the old data from my mortgage class, right? I'm plotting the things from my investment class. Okay, just make sure that these things are compatible. So even if you have small mistakes, once you execute the code, the interpreter will tell you what are defined, what are not defined. So, but here, just in your mind, you should be also clear. Um, I think that's pretty much it. So the figure, okay, I have the upper. Okay, so let's see. Let's see if there's any bugs. There could be. There could be bugs. So execute this. It doesn't plot me anything. Interesting. So there's something not working as. I didn't. Okay, I didn't specify the execution anywhere. So I of course I want to compare investments. All right. I want to compare investments. So I haven't compared anything yet. So that's global variable, global variable, global variable. R rates are defined. I think they are, but okay, that's R. Okay, so then my list of rates are right here. So let me just copy and let's see if there are any bugs. Oh, nice. So yeah, once you have in your mind the roadmap is being clear, then okay, there should be no bugs. But then possibly there are issues. Well, so think about the process. Essentially, you have like yearly investment that are sort of like constant. So you should expect the monthly payment to be certain constant numbers throughout the period. So it's going to be 36 years that you need to work, okay, from the age 34 to 70, right? So, uh, so yeah, let me see. Okay, so here we have 36 data points from 0 all the way to 35. But in fact, there are a total of 36 numbers right here. So that's sort of a curve that you expect to see. But if you feel okay, the label looks kind of awkward, right? So the legend here is overlapping with one of my curves. And if you don't want that, you may want to sort of modify the locations of your curves and the legend location at the same time. So that's one thing you can think about. Another thing here is that so this is the best location that's according to the Python interpreter. But then you should think about the curve. So the initial investment value is going to be 0 for all the investments. And basically, depending on the different interest rates, you would require sometimes more monthly payments, sometimes, excuse me, yearly investments, sometimes less. But in the end, you would need the same target, right? So there are certain options that you can modify the curve in the sense that we start from the year 0 all the way till your age 70, which is the end of my 36 year. So if you feel that your last input, okay, is not so clear, then you may want to also specify, let's say, the X range and Y range. So those are certain settings that we can modify. Mm, so let me also change something about the original data. Okay, so for the figure, mm, so we can do it here. Okay, so this part is about figure setup. So figure setup, let's change the y value. Okay. So I'm gonna do plot dot y limit. I'm gonna make it from, let's say, negative 0.1 to, remember what we had is 750K. Okay, so make it a little bit larger than that. Oh, let me see. We're looking at the figure, which is the yearly investment. That's less than 8,000. So let me make it a little bit close to 8,000. Um, and also let me change the X values a little bit. So xlim is actually specifying the range of my X value. But remember, we have from 0 to 35, which is a total of 36 data. So slightly change it so that it's, if you want a little bit less uh, boundary, okay, within your figure. So let's say 35.1. And let's see how it looks like. All right, so now basically this is basically cutting off all the data that's above, right? So and you have a zero right here, so it's slightly less than zero. So you have the labels, okay, being correct. And then what else? Now if I go from 0 to 8,000, then I have enough space to put the legend at the bottom so that it's not overlapping with my curve. So this is exactly why I'm modifying the XY limits. So sometimes the curves are possible to overlap with certain like the legend location. So you may want to put it like, let's say the bottom left. Okay, so let's do that. Upper center, I'm gonna change to bottom left, so that at least it's not overlapping with your. Something wrong. What's the problem? Possibly there's some spelling error, or it's really up to the location. Okay, lower left should be lower left. And let's try that. Okay, it will be like this. So, but of course, if you say, okay, I don't want lower left, I want lower center, then just adjust accordingly. But yeah, getting your data is one thing, and presenting it in a nice figure is another thing. So there are certain features of the plot that you may want to play with, okay, to make your curves look nicely. Right. And of course, here rounding to two decimals is a trick to sort of like get rid of those unexpected long decimals of your numbers, right? But yeah, any questions so far? So here, so probably I should have made a few mistakes to help with the debugging, but essentially what I can say for now is that especially for beginners, you can try to modify existing code incrementally to sort of ensure that that you are getting the big idea, okay, of the code across. So you do need like a roadmap in your mind to be aware of what needs to be changed and what you want to preserve. So for instance, here we have done like eliminating two out of the four figures, okay, and two out of the four curves. And then, but everything else is pretty much the same from before. All right, it's just the different classes that we are adjusting, okay, to these kind of investments. And you can see the benefit. So once you define the investment class, okay, then you don't really need to pre-locate three different lists, okay? Just remember from earlier, you need a list to get one investment curve, right? But then once you have these classes established, then every object has its own local data, okay? Essentially, they're global. So later, the printout of this live coding notebook will be made available. But for the moment, I would say this is sort of like what we recommend you guys to do, okay? Especially for future like computational plotting. Right? But of course, the bottom line is to be able to plot at least one curve, okay, within the plot. So that's good. So yeah, so I'm not gonna share the Jupyter notebook directly, but make sure to play with it on your own, okay, when we have the time. All right, so that's actually, well, nothing super special for lecture 9. And for lecture 10, it's about NumPy, okay, so that's really important. Uh, Yeah, we may do some notes takings for on our class notebook for today, but so let's see. So NumPy is the high level idea is that, so some of you may know MATLAB, and MATLAB is written in C++. It's super efficient for doing scientific computations, including like function evaluations and very importantly, like matrix multiplications. So it's efficient in the sense that they pre-locate memory, okay, for whatever data structure that you specify. And then for the associated memory, there will be utilizing optimal numerical operations, okay, arithmetic operations to make the procedure fast, right? So that's pretty special. And now what's NumPy? NumPy is uh, the Python version of MATLAB. So basically, it's going to be treating data as vectorized objects. Okay, so like matrices and tensors with very good data structure, so that the computations of the things can be efficient. So that's really the main difference. So NumPy arrays, okay, they are just going to be similar to MATLAB sequences or arrays. Comparing to Python list is that the Python list will have much more freedom in terms of like appending elements, and you can have different kinds of elements within the list. Okay, but for NumPy, it's kind of like homogeneous. So NumPy array intro comparison with this. Okay, so it was like the overall we have touched a little bit, and of course NumPy operations and syntheses. Okay, vectorization, random array. So those are all going to be covered within this section. Yes.
We only have 2 lectures left, and it seems like this in lecture 11 we have very important information for like tools, like learning about the probability of distribution in lecture 11. I feel is probably more important than testing our knowledge on mortgages.
Well, I would say the quiz will not be very much about mortgages, but yeah, well, I'm gonna, yeah, the quiz is gonna be, yeah, the quiz is gonna be about more elementary topics, but then the probability section is actually one thing that's not really going to be super important in terms of the scope of this course, because eventually, if you are actually in the data science program, there's a sequence of statistical courses that you can get more familiarized with these probability theory and statistical stuff. What I can say is that, okay, so yeah, for the remainder of the semester, let's say especially after the quiz, I can I'm gonna give a poll about what topics you would want to quickly go over, because essentially, yeah, we are sort of like getting like a solid foundation of at least you will be able to you would be able to comfortably read through certain codes, especially for the things that you have learned. Later, there are topics like, okay, so this, well, probability and distribution, they are, yeah, they are important in data science, but we do have like a sequence of courses in that regard. And one thing to note is that for certain statistical tasks, they would utilize another language, let's say R. Okay, so which is something completely different in a sense. So that's my personal take is that that's not going to be super important. NumPy topic is definitely important. Generating certain randomized data using NumPy is well, is useful if you focus on using NumPy. But for different packages, once again, for different, there's like an ecosystem of packages. For different packages, there will be different methods and a different data structure that's established there. In the future, if you want to get a task handled in using Python, one option is to directly communicate with the large language model and ask it to give you some specific like beginner tips. And for a certain task, you can ask it to give you like a script template. So one thing that you can do is try to sort of like realize scrapping some like real estate data from online. Okay, so about like a property or something, which is usually not difficult, especially when the data are given online. But now I would say, okay, do we, so yeah, in the rest of the semester, I'm gonna share the rest of the Jupyter notebooks really soon, like at the end of today. But basically, I do see that there's a big list that we haven't covered, including like fundamental machine learning topics. But that's actually a big overlap with the upcoming sequence of machine learning courses. So there's one about optimization. The one after that is machine learning, which is the like for many instructors, they would establish those machine learning methods from scratch. Okay, so this is using relatively simple syntheses in Python to tell you how to do linear regression, support vector machine, uh, and like k-nearest neighbors. So yeah, there are a lot of topics within the remainder of the material of this course, but much of them, okay, I would say 80% are going to be discussed more in depth, okay, in the course of machine learning or in the course of like statistics and probability. So I'm not really familiar with that course in our data science sequence, but we do have a sequence of like 3 courses in that regard. So for instance, in this semester, I'm teaching non-parametric statistics. So that's using the different language of just R, okay, instead of Python. And there are topics like pandas. Okay, pandas is a different dealing with a different data structure versus NumPy. NumPy is all about numbers or like Boolean data. Pandas would be able to utilize non-number indices and non-number data within the data structure of arrays or lists. So I would say all different packages would have like different uh, attributes and methods. But at least on a high level, we need to be comfortable with this kind of different ideas. So yeah, I would say the quiz, I haven't settled on what exact topics we're gonna do. But the thing here is that the code will be the skeletons, meaning that it will not be really lengthy that you need to read like a page to figure out what you need to do. But at least certain tricks that we have established within these past two lectures, they will be reflected in the quiz. It's not going to be super difficult, and certain old topics may reappear as like bonus questions. But for now, I would say, yeah, if you are super interested in certain topics, we can definitely choose some of the notes to go over, but it will not be that in details because we do have a lot that we can talk about. But like I said, many of the things will be more elaborated in more depth, okay, in upcoming courses in the data science program. So, but of course, we definitely need to finish NumPy. In terms of like probability and statistics and the central limit theorem stuff, okay. If you think about the material, it's actually sort of like undergraduate statistics course material, which will take you for like about a semester. But then it's gonna be like an overview of one lecture, which is really sort of like a limited coverage. Um, so personally, I would say that may not be a worthwhile topic for one or two classes. Okay, so yeah. But as for now, we definitely need to finish this NumPy section. Um, probably yeah, probably pandas. Pandas is something interesting. Mm, yeah, like I said, I taught machine learning 592. Yeah, 592 at in this university in a previous year. So I'm aware that much of the material that's in the coming up sections, they are gonna be discussing more in depth using Python. So yeah, well, we can look at that later. Right, NumPy. So yeah, so what's special? It's gonna be homogeneous array. Okay, um, so it's the array. It's just gonna be a list, but it's gonna be a more specialized list in a sense. Okay, so it's gonna be using all floats or strings or boolean. Okay, so but the data of a NumPy array has to be homogeneous, meaning they all have to be the same type. And you would need a pre-located memory, so the dimension is going to be fixed. So if you say let's say it's a dimension of 100 or it's a dimension of like a 3 by 100, 3 rows, 100 columns, then it's going to be there. So it's not eventually changeable in terms of the total dimension. Um, Yeah, and then in terms of, yeah, right. If you go to pandas, we will see that data frames are well built for heterogeneous arrays of data. So that's something special about pandas, which is more related to different kinds of data within machine learning problems. Why NumPy? Um, So yeah, it's basically there are methods okay that are faster okay to search and manipulate in NumPy when you have homogeneous and well-established linear algebraic procedures. So yeah, right here, my NumPy is the Python's MATLAB, and in fact, there are packages that are established upon NumPy, including SciPy, Pandas, scikit-learn. So yeah, well, for machine learning, this course actually touches like the surface of it by doing the fact that for each kind of model, you just directly call a scikit-learn. So which is like a one or two lines, or I believe at most it's going to be like 3 lines to do a machine learning task, which is really simple because nowadays the things are sort of like well established. But of course, in the program like data science at this university, you certainly would want to have like a deeper understanding about every kind of problem. Okay, so that's something you're gonna see more in 592. Let me wait. Yeah, 592. And yeah, 593, I think they will go even more in depth to PyTorch and larger scale problems and more realistic applications. So, but in as a fact that NumPy is sort of like a MATLAB. It's kind of like the numerical computational fundamentals stuff. Right. Basic syntax. So what do? You need to import NumPy as MP, so that will be easier for you to type. But then it's going to be just the mp.array. Okay, so for whatever list that you have, you can directly convert it to a NumPy array. So now if you look at this is a list of lists. So originally you have the first element of your list is going to be like a one-dimensional list of 1, 2, 3, and then the second element of your larger list is a small list of 4, 5, 6, and the third element of my larger list is my small list 7, 8, 9, right? But now there's a difference here. So what's special about this kind of NumPy array is that they would give you a special type and let me also yeah, here I may need to kill this off. So the type is numpy.endArray, right? And then if you print A, it's going to give you something like this. So it looks kind of weird in the sense that, okay, the list is like this. So they give you the list, but then if you directly do the output of the cell, it's going to be an array of that, okay, which looks a little bit weird. But when you print it, it's printing you a different thing. So this is really special because the reason is that the str, okay, the string of your object is now modified. Okay, so now I'm gonna run this code again, but now you can see the difference. A is printed as displayed as array of 1, 2, 3, 4, 4, 5, 6, 7, 8, 9, right? But now if you print, it's now looks like a matrix without the commas. Okay, so this is like a special written str function that's within the class of NumPy array. All right, now you have seen the str functions. Now you see what I mean. So now the thing looks more mathematical. All right, so like a matrix right here. So yeah, just you just need to call the method, okay, array, okay, to convert whatever list that you have. All right, so now it can do something, let me see. It can do something special. So earlier when we have addition of lists, okay, so it's just putting the elements together, all right? But now in terms of NumPy array, you can add element-wise. So here we have L as the list of lists again, 1 to 2, 4, negative 3, 1, 12 to 10, right? So now you are actually adding this, you're converting this to a NumPy array, which is, well, still that matrix like this. So the first row is 1 to 2, adding to 1 to 3 here is going to be that 2, 4, 5, just as expected. Okay, so this is element-wise addition. Okay, we have printed the type array already, so it's the yeah. So let's print it again. So it's the type is really special. NumPy.end array. Okay, so it's what's making the thing special and efficient. Mm. All right, so okay, yeah, so that's pretty much for today. So yeah, we'll do the quiz and then we're gonna continue the section once the quiz is done.